Cool. So, good morning, Mr. Technitis. I'm calling from Switzerland, and I see your profile on LinkedIn fits one of the job openings we have. Would you be interested to discuss a bit about it? It says Swiss Re. You mean the airline company? No, that's Swiss Airlines. Swiss Re. Like reinsurance? So, yep, and what is that? Like, it's the insurance for insurances. It's a big thing. So, okay. I'm sitting in Santa Barbara, actually traveling down Malibu when I received this phone call. I come from completely geoinformatic background, so entering into insurance was kind of a big thing for me. It was in the middle of chaos, knowing absolutely nothing about it, other than they need someone with geodata capabilities. For me, back then, insurance was Excel sheet. Turns out that it's not exactly like that. But why is it interesting for us? Well, we start from the basics. Not these basics. Perhaps these basics. I'll keep trying till I get something. There you go. So, the basics is the market itself. I see the difference here, but not there. Let's try again. The market. The market, reinsurance market, 170 billion. That sounds big, but then insurance market, 3.8 trillion. That's even better. Keep in mind, Swiss Re is a very nice set of puns where you have a reinsurance pocket and an insurance pocket. These two are not allowed to communicate other than IT and money. So no data transaction, no anything, just knowledge, IT, and money. I come from the IT, so perfectly fine. I see behind the Chinese wall. But what is important is that the situation is a bit more complicated. Let's try. There you go. You see why we have the animations now, to keep you busy while we're trying to solve things. So the market itself shows very, very, very slow, not even steady growth for the past 8 years, and it looks like it's going to be like that for a bit more time. What is more important is that 70% of the customers start acting like Booking.com. So I will read your review before I come to join my next insurance product. And then on top of that, we have such a huge change in law regulation. From IT to internet to privacy, it's extremely difficult to release new products into insurance right now. So what you see here is that there is no significant growth. You have difficulty to maintain your clients, and you cannot release new products in order to increase your client share. All that, to me, translates in a bit of a lack of trust. It's a lack of trust from regulators to insurance companies, from insurance companies to the people, and definitely from people to insurance companies. And this is where we try to do something about it. We, being GDM, geodata modeling, it's not important for you, but it's good enough to know that we want to extend our geo reach. We try to geo-enable our data, and we need to do that now. Let's try to go deeper into that. What you say we do is that we play with coordinates. We do contextualize our data, and we monitor our assets. These are 3 of the main reasons that business comes to my desk. What we actually do is a bit more complicated. We just demystify capabilities, we tailor it for the purpose that the business wants, and then we inspire. Inspire with a dot, please. This is the most important part. We really try to inspire, not just solve something, but to inspire through our solutions. Let me get into that. Demystifying capabilities. That's a very nice Sentinel picture. This is what we call satellite imagery. When we say about Landsat, satellite, etc., that's what we think. When we communicate that to the business side, they think of Battlestar Galactica. That becomes really, really difficult to explain that, you know what, we cannot solve everything with a black box. It's really, really many things that we can do, but not just exactly that. But then the question comes, but what can you do? That keep popping up, so I decided to make a list of things that you can do based on remote sensing geointelligence. I mean, this list goes forever, but I decided to stop it here. And then out of this list, not everything is relevant to insurance. So I selected the ones that are relevant to insurance. You can see it a bit with blue letters. And then there are a couple of red lines there. I would like to just demystify these capabilities. Using habitat suitability models to predict the abundance of mosquitoes. Now, when you think of mosquitoes, you don't think of insurance necessarily. But if you go, anybody from Canada around here, perhaps? Ah, there you go. Thank you. So I'll be very careful with what I say now. Thinking about the borders of Canada, you have these mosquito attacks. It's almost a plague, really, where there are so many mosquitoes around the lakes, around 1,000 lakes, that the actual animals get attacked by mosquitoes. I mean, I was thinking of putting a picture here. It's actually very, very repulsive, but the point is that if you see it, then you cannot unsee it. Think of a goat walking and then attacked by a cloud of mosquitoes. Every square centimeter is filled up with mosquitoes. I mean, animals die there. And the interesting part, the geographic part, is that if you maintain the same temperature or elevate the temperature by 1 degree for 1 day at the lake, given all the rest of the humidity, etc., stable, the population of mosquitoes doubles. Like double. You have double the millions of mosquitoes just by a single temperature maintenance or increase. Now, this is very difficult to put in a model, but it's very, very easy to calculate in real life. So you have a satellite information, you find the lake, you start calculating the humidity, temperature, etc., and you have a funny model that for me was kind of a 2 hours work, and that meant something to someone which is apparently huge in Canada. That's one demystification. And how about the predicting fuel pricing? That was even better. I know nothing about fuel pricing. I definitely don't work in finances. But what I do is to work on satellite imagery, going globally on oil refineries, and then see if they have oil in it or not. Perhaps with interferometry like radar, you can calculate approximately how much it is in there as well. So all I did is just to try and find these kind of balances around the globe, and then saw the time series in the historical data of the price, and I saw that there is 2-3 months of lag, and then suddenly you can predict a bit the price. I don't know how, I don't know why, but this is kind of, you reach it up to that point, and you break it down to very simple geographic questions. So this is kind of the things that we do, try to take something rather complicated, seemingly complicated, and try to see if there are easy ways to go around it. Of course, once you do that, then you come to the second problem. Everybody comes to the desk asking for a Ferrari. Like, hey, I know it can be done. I know I can predict the global economy based on remote sensing. Yeah, okay, but then that becomes a bit more complicated. What actually happens is that most of the people come for a Ferrari while they want to go on family vacations. And this is a true example of my last presentation, actually. It was an underwriter. Do you know what is underwriter? Not really, right? Think of it as so me and you are here, the 10 of us go to a broker in order to have insurance, any kind of insurance, then 100 brokers go to one underwriter. That underwriter is in Swiss Re and trying to give a price for all the rest. So that person comes to me and says, hey, George, I would like to have a very accurate calculation of damage after every NatCat event in US. And I would like to have that 3 hours after the NatCat event. You have a tornado, everything is got damaged. I need to know what is the damage at every house 3 hours after the event. Is this possible? Of course it's possible. Okay, when can I have it? In 2 months. So, sounds great. So when can we start? So, well, the price tag is 1.2 million. Side note, this actually is close enough the magnitude of the price tag. I said, so this can be done, 1.2 million. When are you ready to pay? We can start. I said, 1.2, that's a bit too much. So, well, how much would you be willing to pay? I said, well, I don't know. I said, would you be willing to pay 600,000? Yeah, it's a bit too much still. So how about if I decrease a bit the accuracy of what we want to demonstrate? So, well, that could work. And how about instead of 3 hours, we go up to 1 week, like not more than 10 days, let's say. That could work. Cool. That will cost you 50K. 50K? That's perfect. Yeah, actually the solution is for free. The 50K I will use it for another project. This is kind of how you start monitoring, like what exactly is going on there. We came up with 3 very simple ways to assess the business questions. Complexity, sensitivity, cost. What is best, when, and how it's going to be implemented is directed by these 3 requirements. Let's go to a very simple example. We have multiple satellite imagery trying to scale globally, and we want to have very specific analysis on it. It's not important what it is. It can be from crops to flood to population dynamics. It's not important. What is important is that we need a tool that actually facilitates this process. And we have 3 vendors that they can facilitate us. IBM Pairs, it's the developer's choice. It's amazingly cheap disk, full continent for 10 euros, that you have all the terabytes or petabytes of information. You have amazing business support. It doesn't get better than IBM. Do you have any version from IBM here? Thank you, cool. So we have amazing business support, and it comes with a very expensive fee. You go to the Google Earth engine. Amazing, well, unparalleled horsepower. It's amazing to work on that. You just keep going, throwing things at it, and it returns results in near real time. It's amazing, really. But if you want to deploy your machine learning training data, that's becoming public. All your scripts that you run, all the pipelines you run, everything is public. So can you handle that in an insurance policy kind of setup? That's more difficult. And then you have Exolabs. Exolabs is a spin-off from a university, University of Zurich, which is a bunch of PhD, really motivated, romantic students that they put together amazing research, and they deliver very tailored result with pricing that corresponds to PhD salary. So it's very cheap, not very well documented, but you have full support. And whatever they have, they will just give it to you in the best way they can. So practically, developer selects IBM. Geoscientists like me will work for Google Earth, but then if you want to have to deploy your own data, Exolab seems to be the perfect choice for client. When a client comes to you, doesn't know about Exolab. When a client comes to you, knows about Google Earth, and doesn't want to pay IBM. So this is kind of how the story goes. Of course, this is a bit kind of abstract, so we need to formalize that. And that brings us to the vendor assessment. Vendor assessment. You have the specific kind of tagline, what you want to do, automated NatCat damage assessment based on remote sensing techniques, 1.2 million. You have a desk research, first contact, you have like a bunch of vendors that start with, then you move to a Shark Tank event. You give them a POC, they run for 1 month, they deliver the results, and then you bring them in Shark Tank. Something like that, plus 11 members of all the head of geo, head of data, head of privacy, head of whatever, in order to see if it makes sense to them. Out of them, we selected one, the Geospatial Insight, and we said, okay, let's now run a proof of value, actually. First event in Nebraska floods. Nebraska happened, and we got a trigger, let's say. Trigger that we want to cover this event. It was not 3 hours, but it was 3 days, and we got covered that in a way that it could be used by the underwriters. So all that, it's discussions that take place after the inspired kind of discussion of 1.2 million, etc. And this brings us to the actual inspiration part. While trying to detect the floods, etc., I was playing around with a bit fuzzy logic and trying to analyze and actually dissect the data. So you have this image here, and then you have this image here. So this is what we see. This is what the computer sees. If you can see, like I've highlighted a couple of the areas here. It seems like quite a good result, and then based on the metrics behind, it's actually a very good result. But I have no idea if this is actually helpful to the business guys. So I took the results and packed it up in a kind of a different setup and tried to approach business people. Business people took it, and they said, okay, that's interesting. Let's try to do something about it. I explained them the pipeline. We discussed on the outcome. And apparently, what I was doing as crop identification, etc., they moved it a step further. We go to yield estimation. I said, okay, let's try to tackle that. And that would be the day 1. Day 5th, we read everything is online. We start deploying all kind of algorithms we found. Seems quite interesting. All my geoscientists are quite happy. I'm even happier, to be honest. And then in week 3, we have our first platform. By the way, this is my advertisement for CARTO. They actually used quite helpful there. I'll show you a bit why. So practically, we started developing all that. In week 3, we're already up and running. Please keep in mind, yep, that's day 5, week 3. From week 1 to week 3, this is how much we needed to get authorization for the cloud to get up and running. We were not working, we were just waiting for authorization. This is what happens in big dinosaur kind of setups. Week 5th, we started implementing more vendors, more open data, further more applications. We tried to become as agnostic as possible. And by week 8, we have our first big result. We tried to analyze all Brazil. We did it. Actually, this is quite a bit of terapixel processing. Is quite significant for a company like us that we're not a data company. And allow me to say that it's actually quite nice for companies that are related to data as well. I think that even IBM was trying to cope up with that. So we know that this is something big, but we also know that this is something useful to business because we included them in the pipeline of creating it. And then we tried to visualize that. That is Kepler. That was a good start, a free start, but then we decided that we need something far more professional, and that's where CARTO entered. But then we also saw that in order to deliver these insights to business, it was not good enough to just visualize things. We gave them the API. They were like, okay, that's good. And then visualization, oh, impressive, but how can I use it? And then we gave them an email service. Like, you click the email, you send the email with location and time, it fires up a VM, does the classification, result somewhere in Dropbox, and then a link for you to download it. That was the hit. All the rest didn't matter. The moment they saw the email, oh, that's really useful. I said, okay, so let's discuss about it. What I did see out of all this exercise is that all the people that come with the problem, they try to solve a problem yesterday. They need to solve a problem now. It becomes so competitive outside in the market, inside the same company, in order for each group to deliver results, that the metrics are all short-term. I find that this is a bit difficult and not entirely unfair for geo products. The geo product is a long-term investment. You cannot have short-term metrics. And this is a bit important on the business model, how that impacts the model. So the inspire part is a way to motivate people, to cultivate people, to create a new culture in order to start tapping these kind of problems the way you should. And this is kind of the wind of change, what I call wind of change. You have plenty of fears that help us here. Reputation risk, disruption risk, fear of missing out, and competition. Reputation risk, if you're working on marine industry, you have vessels going around the world and you insure these vessels, and these vessels go to the war zones. All this information is online, you can find it, like you personally. If us as insurer don't take advantage of that, not advantage, but take control of that, then suddenly we have reputation risks going on. Disruption risk, of course, every new company, new spin-off comes and takes a big chunk of the market. The fear of missing out, a new spin-off is about to start. How about investing before that? I literally had companies that they come with a business plan on a napkin asking for billions. And I only marginally exaggerate on that. And then you have, of course, competition. You have two big companies that they're fighting for the same share, a bit more, a bit less. This is kind of, you try to have the edge, the extra edge. But you have also needs. The needs to contextualize your data. You have tons of data, like historical data. You try to contextualize and try to make something more out of it. You try to scale up solution. It's not good anymore to solve something in a local Madrid neighborhood. You need to expand it to Spain, to Europe, to the whole continent. You need to be transparent. You try to bring back a bit of the trust that it's missing so far. And of course, all this kind of geointelligence and, well, CIA helps a bit, even though it sounds a bit funny. And here's my favorite part. This is an ode to machine learning and machine messing. As you develop all these algorithms and we try to control a little bit of our extra 1% of accuracy and a little bit of better data, etc., we often come into these kind of setups. Now, what you see here is the data that I got. Now, there was thousands of data points of all the crops in one specific area classified. George, this is the best data you've ever had. We're very proud of having this data. That's going to bring us the edge against our competitors. So I started working on that. The machine learning was really, really going south. The results were really, really bad. And then I was trying to figure out what the heck do I have there. Now, do you see these kind of interesting parallel lines? So what happens here, forgive me, what happens here is that I'm a farmer. I go to my farm, and I click with my GPS, noting that I have corn. That's all. Then the next farm goes to his or her farm, and I have soya. Now here what happened is that the farmers were in the truck as they were driving through the farms. They would say, oh, that's my farm, corn. Oh, that's my farm, yield. I'm sorry, soya. So practically, you literally have 10,000 pinpoints on the street, which they're classified as some kind of corn, and you try to train your model out of it. And of course, you can control about it and start removing all this dump data. But the truth is that when you start developing the product, you depend on this data. You take a sample, you try it, it works, so let's go further. When you receive the full data set, that's becoming really, really messy. So trying to communicate back to business why that is not really, really possible, that's a bit tricky. That's when we try to enhance our labels. Enhancing our label is like, the label data you gave us is not good enough. How about going and trying to do something out of it? It's the classic captcha thing. Like there's a company called Hive, which is really interesting. They try to, so which of these pictures have cars? That's what you do. You click on the picture, that's pretty much it. And then potentially where this car is, you can also polygonize around the car. Sounds a bit interesting. They have by now 2 million users. I mean, they fire up the pipeline really fast, etc. In order to be a bit more depictive, well, actually, I have a small example, I think. Yeah, that's the car. So where is the car? You try to polygonize a bit, and if you have 3 people that polygonize exactly the same area, then that's the correct answer. That's pretty much it. Now, how does that work in real world? If you're a student in Germany, and you need to make some extra money on the side of your studies, what you do is you go to one of these companies, what they call Wafer Companies, where Wafer pays, like the companies pay a lot of money for advertisement of the logo while the football match takes place. So practically, if you see a Goodyear somewhere, for some reason they paid a lot of money to see it on the TV. So they put students to validate that the Goodyear was actually shown there. Now, if you do that, like you have 10 students watching all the matches like that, and click, 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 shown, shown, shown. So that is in the football match. Now imagine that in F1 Formula, like things going really fast, and logos are everywhere. So that is the task. How about finding all the logos everywhere in Formula 1 real time? So okay, how are you going to do that? 2 competitors survived this challenge. One was Google, and the other was Hive. Google, don't account me for the numbers. The number was, it was 40%, it was 60% accuracy with 40% total coverage of the logos. And then Hive, with the manual workers behind, it was 80% coverage with 89% accuracy. And in order to be more explicit about it, that's not the logo that we're trying to find. Just so. If I click, is cool, perfect. So imagine really dramatic music behind. It's really, but the real point is to just point out what is going on here. So this is a level. This is machine learning algorithm based on the label data that took place with Mechanical Turk, with actually human interaction. So you do see that this is something well, unseen before. It's something that is quite cool, and was something we were trying to justify in a business case, and suddenly agriculture became a good business case for it. It works really, really well. And more of that coming up. You see, it would start. So what actually happened in this kind of setup is that the insurance, a traditionally conservative kind of business domain, accepted a person like me, like many of like-minded people that were quite entrepreneurial, quite geoscientific oriented, but we're trying to apply that in a business environment. So they really, really gave us a small cloud of protection in order to get us started. And at the end, we started having some actions. That's really funny. Let's try again. There you go. Some actions. So we started fusing data, then having behavioral analytics, working with time series, aviation, crops. We started having, well, pandemics, etc. I'll come back to that. Marine was one of the big cases, smart homes and all the rest. All these are projects that somehow tapped into into our GDM, geodata modeling. And at the end, what we do is, as we suggested, we geo-enable our data. And by that, we multiply our reach. And this is something quite important. I would like to give this final comment to all the people that they sit behind a terminal somewhere in any kind of geo-inspired location. It doesn't matter if it's CARTO or anything else. Every person that actually books a ticket for someone, every person that creates an algorithm that does something a bit better, that person creates a result that someone will see, and if inspired by it, then we start having better reach. And what that actually allows us to do is to have a bit more time to work on things that matter. Because yes, insurance is business, but the insurance values behind its resilience. It's about people. So being able to have this extra reach allows to work with pandemics, allows to work with things that affect people immediately, even though you don't make money out of it. So please be sure that every little bit that we get, it's actually working towards that direction. Thank you very much.